Hello students. So in the first video we solved a few logarithmic equations. In this video we're going to see some applications or word problems. You're going to need your packet and a calculator and a pencil so you can work with me. So I will start with number 19. Let's read the problem. So we have $20,000. Oh, that's not a good. Let's try this one. So I have $20,000 is invested in an account earning 5%. The interest is compounded continuously. Determine how long. So that's the question. How long? That means I'm looking for time. We'll take the money to grow into 45,000, round to the nearest year, and we're going to use the formula that's for continuous compounding. So in the formula, I'm going to put the numbers in the formula. A equals PE to the RT. The A is the amount of money after you applied the interest rate and the number of years. So what will the money be after that many years? So 45,000 is equal to P is the original amount of the money, the principal. So that's 20,000. E is the universal number, which is 2.718. You don't have to put 2.718 because your calculator has a built-in key. Or as a decimal, it's going to be 0.025 and T. Remember, we're solving for T, and T is in the numerator. T is in the exponent. So in order for us to solve for T, I'm going to have to isolate this exponential expression here. I need to isolate it. To do so, I'm going to divide by 20,000 and divide by 20,000 just to get rid of that. So I end up with e to the 0.25t is equal to, and if you use your calculator to divide 45,000 by 20,000, you get 2.25. I still have t. Notice that t is still in the exponent. The only way to bring t down from the exponent is to apply logarithm for both sides. So since the base is e, I'm going to use natural logarithms. ln e to the 0.025t is equal to ln 2.25. And then I'm going to apply the power rule to move this in front of the ln. So 0.0225t ln e is equal to ln 2.25. But ln e is 1. So it's like I have 0.025 is equal to t, of course, is equal to ln 2.25. Now, to isolate the t, you're going to divide by 0.025, divide by 0.025. So t, you can enter this on your calculator. So I'm going to end up with t being 32 point, I already entered this in my calculator, years. So if I invest $20,000 at 2.5% interest rate, compounded continuously, it'll take the money 32.4 years to grow to $45,000. Now we'll discuss number 20 in our virtual meeting. Let's do number 21 together here. I will do 3 problems in this video, and then we'll answer questions when we meet a line. Let's read this problem. The population of a certain city, Perville, is Y, and it's decreasing. And they gave you the mathematical function which determines the population. Now, use this model to predict when the population of Perville will be 100 people. So that's the model. They gave you a certain function. So Y determines the number of people. So when will the Y be 100 people? So I'm going to enter that into the equation. So 100 is equal 160,500 times 0.76 to the power x. X represents the time, the number of years. Okay? And we're solving for x. Again, this is an exponential equation because x is in the exponent, and we're going to need to bring that x down. To do so, we're going to isolate this expression, exponential expression, by dividing by 160,500. Divide by 160,500. Again, you're going to need a calculator to do so. So I end up with 0.76 to the power x is equal to, if you divide this number right here, I got some decimal, so I tried to put some digits. It's a very small number, 623. Now, in order for you to bring that x down, you're going to have to use logarithms. I can use log base 10 or log base e. Let's use log base 10. So log 0.76 to the x is equal to log 0.000623. And I'm going to finish here. Now we use the power rule. So I have x log 0.76. I don't think I have enough space here. So x log 0.76 is equal to log 0.000623. That's a 0. Okay. And then I'm still isolating the x, so I'm going to divide by log 0.76, divide by log 0.76. So x is going to be this number right here, which you're going to enter in your calculator. So it's log 0.000623 divided by log 0.76, and that's about 27 years. So in 27 years, the population of Perville is going to drop to 100 people. Let's continue. And I'm going to continue to number 23 here. Mr. Julio wants to double his money in 10 years. Well, we don't know how much money he has. All we know, he wants to double his money. So if he has 5,000, he wants to double his money in 10 years. So he wants 10,000. Find the rate. So I'm looking for the interest rate here. He would need if his money compounds continuously. Okay, in 10 years, that represents the t. And the formula for continuous compounding is A equals P e to the RT. Now, we don't know the P, the original amount of money. We know that A at the end of the 10 years is going to be double of P. So A is twice of P at the end of the 10 years. So instead of A here, I can put 2P, because after investing for 10 years, the P is going to grow to double, which is 2P, is equal to P E. We don't know R, but we know T, it's 10. Sorry. We're given T to be 10. So now, if I can get rid of P because that P is not even given. So if that's how I get rid of that unknown. So P cancels out from both sides. I have this equation, 2 equals e to the r times 10, or 10r is the same thing. Now, in order for me to solve for r is in the exponent, so I'm going to have to bring it down. I do ln 2 ln e to the 10r. And then I'm going to use the power rule of logarithms. So ln 2 is equal to 10r ln e. But ln e is 1. We already know ln e is 1. So I really don't need that because 10r times 1 is 10r. So to solve for r, I'm going to divide by 10. That means r is, now you're going to have to do the, r is this number, you're going to have to do it on your calculator, which gives me 0.096. I think it gave me 0.0693, and as a percent, this is as a decimal, as a percent, it's going to be 6.93%. Now, you're going to finish the rest of the problems, the ones that I didn't solve today in this video. If you have questions, you're going to have to ask those questions when we meet online, either Monday, Tuesday, or Wednesday, Thursday. Thank you, everyone.